May or may not be done. That's okay. There's a couple of things I want to talk about, then I'll let you get back to it. First thing. Number 4, the first 3 questions are just there to get you to start understanding opposite, adjacent, and hypotenuse automatically. Okay? And knowing where they live in any given triangle. So the opposite of angle A, in the first one, you could have said GH, HG. You could have said 6, but I don't know why you would have. Some of you wrote little a, but little a doesn't really tell me you understand what opposite is. Do you understand what I'm saying? Everybody with me? So you would have been better to do GH or HG. Everybody cool? But if you actually wrote a little a over there, that's cool too, because then that tells me you know you go opposite. Everybody good? The whole point of work is to show the person marking your work that you know what you're doing. Yes? That's the whole point. So anyway, everybody should have been good with that. And then B, the reason B is there, because sine A, for example, is 6 over 10. Right? Opposite over hypotenuse. But it's also 0.6. A lot of kids forget that this decimal is just whatever the fraction is after you punch it into your calculator. Okay? Remember back in our notes when we found 0.267? And I said, now that's also 267 over 1,000. So you could draw a triangle that had 267, because it was tan, over 1,000. Or 26.7 over 100. Or 2.67 over 10. Everybody with me? That's the point of this question. You're seeing it as a fraction, but as always, all fractions are just the decimal once you've done the division. Okay? Everybody good? These ones, of course, you're just punching it into your calculator. Sine 57. Why is that there? Because half of you have different calculators. Well, not half. This is actually a really good class, considering mostly there's a lot more backwards calculators than there is in this room, which makes my life easier. But there we go. So, of course, for me, it's sine 57. But I have to be in degree mode. So it's 0.84 for me. If you don't have 0.84, your calculator's in the wrong mode. All right? Now, listen to me. Obviously, what is the largest value you can get for sine? Talk to your neighbor. Not the biggest angle, the largest value you can get for sine. Who has an answer for me? Hannah. 1. The largest value you can have for sine is 1. Because sine is a ratio. Right? And it's opposite over hypotenuse. The opposite must always be shorter than the hypotenuse, yes? Except in only one case. Is the screen blue? Of course it is. Oh, you are such a piece of garbage. This is 90, yes? What is opposite to this angle? B. What else is B? Son of a B! It's the hypotenuse. So the opposite and the hypotenuse are the same thing. It's going to be hypotenuse over hypotenuse, which is 1. Everybody cool? What's the largest value I can get for cosine? Hannah. Of course it's 1 again, because it's adjacent over hypotenuse, right? What's the largest value I can have for tan? Nope. If I had theta right here, and this was 1 trillion, and this was 1, what's the tan of that angle? Infinity is the largest value of tan. Because I can always go up forever and ever and ever, even if I only go over 1. So that would be, if I went up 30 bazillion, it would be 30 bazillion over 1. Right? Okay, good. So, number 6 is just what I was talking about. 0.25, if I were to draw it as a triangle, there's x, 25 over 100. Everybody cool? Because 25 divided by 100 is 0.25, yeah? Okay. And down here, what? Yeah, of course, because the angle is 14. This is what the triangle would look like. This angle would be 14, because you would have done shift sign. I'm doing this to show you that the decimal comes from the triangle. And then down here, if I start at angle C, what do I do to find it? Sine or cos? Cos. And once I know angle C, how do I find angle E? I got 2 options. What are they? I can do the 180 thing, or I could do sine. Who makes that decision? You do. Is one way better than the other way? No. You make the decision. In B, if I start with angle H, what am I doing? Sebastian. I'm sorry I can't hear you. I want to hear you, but when you ask a question, now I can only answer you, and other people are going to ask me the exact same question soon.
Is that a typo if we're trying to find
Probably.
D because it's a right angle? Or where are we?
I would assume so.
Yeah.
It's
Okay.
probably supposed to be C and E.
Or E,
You'd use sine. Good. Okay. Listen, please. You will have noticed that every question on this page has no real-life application, right? It is just practice. How we use trig in real life, we use it to find distances and angles that we cannot measure. That's why we use it. If we know some distances and some angles in a triangle, then we can find all the rest. Now, every single one of you have seen, and it's going to sound sexist, but it's 99% of the time it's a man that's doing this, so please don't think I am being sexist. You have all seen those dudes on the side of the road looking through a telescope at some other dude far away who's holding a flag, right? When they're building stuff on the road, right? You've all seen that, yes? Guess what they're doing? They're doing grade 10 trig. That was a good one. And they are doing that because they need to measure distances of things like pipes underground and stuff like that, where they do not want to dig a big hole, measure the hole, fill it back up, come back, tell people this is how long the pipe needs to be, go back and dig the hole again. Understand? Same reason they do it over roads. They don't want to stop traffic so they can measure. So when you turn the page over, you will see onto page 58, we start with random triangles. It is not sine, cos, or tan. It could be any of the three. And we end with a real life type of problem. Because that's where we're leading up to. Applying trig to real life. Okay? So, if you would all be so kind as to start on this page. And I will give you